It's improper, so we can make it a mixed number.
Oh, that's what it is. How many times does 4 go into? It'd be something in 1/4.
Mm-hmm.
No. It'd be 9 1/4.
Correct.
How many more do you want to do?
Let's do 15.
Okay. So we got 24 divided by 1 and 1/5. So 5 and 4 plus 4 is just 6. So 6 over 5. And then the first one we have 24 over 1.
Mm-hmm.
Change.
So keep the first thing, change this to multiplication, flip this.
So we got 24 is divisible by 6.
Mm-hmm.
And we use 4.
Mm-hmm.
And then that by 1. Okay. So we can go 4 times 5 to give us 20.
Correct.
And then 1 times 6.
So the 6 got canceled to a 1 though. Forget.
Oh, 1, sorry. Oh, so it's just 20.
That's right.
Which is equal to
20. Good. Let's do 17.
17. Alright. Let me try this one. Okay, so it's subtraction. 4 times 6 is 24. So 24. Oh, plus 1 is 24. 4 minus 7. This equals times this by 2. Times that by 2, so it's going to be 50 over 8 minus 7. This gives us 43 over 8.
Good, I got that. Okay, good. So that'll be it. That's like fraction math. So you got multiplication, division, add, subtract. Let's do let's try a couple of these. Like number 9.
Number 9, so 4 times 9.
Yep. We'll just do a couple of these, see how this goes.
So let me write this down. 9 is 39 times 4. So 4 times 8 is 32. So 2 down there. 4 times 4 is 16. Plus 3 is 19. Carry the 1. Decimal. 4 times 9 is 36. Plus 1 is 7. 4 times 3 is 12. Plus 3 is 15. So I get 157.9.
Good. Let's do some division. 17.
Ooh, 17. Okay. 1.5. 1 by 155. Right. So 1.5 can go into 1. They can go into 13.
What was the first step here? We want to move this decimal.
Well, that's the first step.
So if we move this here, that means we can move it move one over here.
Nothing like that.
So it's equivalent to 1,350 divided by 15.
Okay, but so we need that by 0 to become 15 divided by 1,350.
Mm-hmm.
That's a bit easier. 15 still can go into 15. Or 15 can go into 35. Or 135.
Mm-hmm.
30, 60, 5, maybe probably go 9 times.
9 times, right?
Put the 9 and then that is 155. 0, and then 0. 15 can go to 0, 0 times.
Mm-hmm.
0, 2 times 0 is 0. Minus 0 is 0. So would we have to put the decimal back, or is it just
90.
or 9?
90 times. So 90 times 15 is 1,350. Or 90 times 1.5 is 135.
135.
That makes sense, right?
Can we try one more?
Yeah, let's do another one. Let's do 18.
So carry the decimal over.
Yep.
We do 2 or just 1?
Just one. This is the number where it has to be whole here.
Okay. 7, 29, 23.
Mm-hmm.
7 can go into 29 4 times with 28. So it gives us 18. 7 can go to 18 once. Which gives us just 7. 18 minus 7 gives us 6. Here we go down to 3, so we add a 0 and pull down a 0.
Yeah, add zeros.
So gives us 60. Would be 8 times
Mm-hmm.
with 56.
Mm-hmm.
That's 4. We got another 0. 49. This would be 35 with 5. How many zeros do we have to have to create 1?
Yeah, so like they say in the instruction, round the answer to 2 decimal places. So we already have enough. And so the question is, how do we round this now to 2 decimal places?
So we have 1, 4, 8, 5.
And then don't forget did you bring the
So
decimal?
the decimal, sorry.
Yeah.
4.185.
Right.
And then we round the 5 up to 8 to become 9.
Mm-hmm.
So you're 1.8 or 1.
4.19.
Is it actually 2?
Yep.
It's
You okay with that?
Yeah.
Okay. So that's long division. I just wanted to do a couple of those. I want to get into a little bit of algebra stuff here. Let me see if I can find where it is real quick. Number 1. This is what you would call like as algebra, like solve for A kind of a thing.
We're solving for A now.
Yep.
Alright, so it gives us 18. I've been doing this backwards. It's been a while since I've done something like this.
Good. That's how we practice.
Do we put it over 9 or do we put it over 1?
So the first thing we want to do is we want to get the
Oh, A by itself.
this So we're trying to get A by itself. We want to get do the Go ahead. I'll say that and let you
I
go.
remember.
Okay.
So we draw a line equal sign. Minus 3 equal signs.
Good.
Which gives us A is equal to 10.
Mm-hmm. Good. A equals 90. Good. Yeah. Yeah, it's good. And that's what math is. You have to know everything from the first day everyone took math. That's right. Let's do 2. Mm-hmm.
So 2 equals 4.
Good. Let's skip to 4.
0.6x equals 42. So, draw the line. 0.6.
Mm-hmm.
Divide 42 by 0.6. Is it okay if I use my calculator to figure out what 42 divided by 0.6 is?
I prefer not.
I think that's my next.
That's fine. Yeah. I mean, you could if you wanted to, but it's better to do it like this.
What's the fastest way to do it?
Okay. Good question. So we could do long division. We could do this again like we were doing before. You can take any fraction and write it in long division. Another thing you could, yeah, another way to do it is say, I don't want decimals in fractions. So one thing I can do is multiply the top and bottom by 10, and then I'll clear this. I can
add 0 to the top and put the decimal 1.
Yep.
So you got 420 over 60. There's like 6.
Mm-hmm.
What would you do with that information now?
So like you know that 6 goes into 42 for sure.
42, yeah.
See what I did there?
I see how you got 6 goes into 42 7 times.
And then
6 goes into 0 times.
Yeah, so it's like it's just do it like this and then just add the 0 at the end. So 6 times 70 is 420.
Okay, I got you.
Okay.
So with that 70, your 42 divided by 0.6 would equal 7. 70
Mm-hmm.
would equal 70.
So x is 70 in this
So
case.
x equals 70 in this case.
And if I plug 70 back in here, 70 times 0.6 is 42.
Would give us 42.
So you can always check. Let's do 5.
0.51 equals 11. Okay, look. Divided by 0.1. you said let's times of both by 10.
In this case, we want to move the decimal place twice.
Or do you want the denominator?
Yeah, we want no decimals left.
No decimals left. So we would times it by 100.
Yep.
In this case. Times 100 times the device. That's right, 3,500. No, that's way too much.
Yep.
350.
350.
And then the bottom would give us 25.
Mm-hmm.
So 25 goes into 100 and 4 times.
Mm-hmm.
So 4 times 3 is 12 plus 2, which is 14.
Beautiful. That's what we want.
14. And then 14 went to 0. Did I do that? Or would I actually do 14?
So you do like dividing top and bottom by 25. So 25 over 25 is 1. And this is 14.
14.
Yep.
So this, in this case, y equals 14.
Yep.
Awesome.
Nice. Number 7.
Right. 2 over 3 equals 4 7. You want 2 by itself. Or you want data by itself.
Mm-hmm. Mm-hmm.
On both sides.
Good.
So this gives us just 2n is equal to 20, sorry, 12 over 21.
Okay, check that. So if you multiply both sides by 3 over 1.
3 over 1. Oh, sorry, 12 over 7.
Yep.
That's 12 over 7 is equal to 2n. And then now, we divide 2n. We divide this by 2. And we have to divide that whole fraction by 2. And like that. I see it makes sense on paper, but it's not making sense in my head.
Okay.
I find figure
There's
out
probably
what's
a so let's not do that.
really-
Let's multiply both sides by a half. And right from the beginning, actually, let's step back. What you did was perfectly fine, but there's a different way to do it. I want to get n by itself. So what I can do is, and I know there's a fraction over here, I can multiply by what's called the reciprocal. I can flip this.
Everyone's about not understanding that.
Yeah. And so this is a nice technique because then this is all going to turn to 1. It's going to give me n by itself like quick and right away.
Right away. So I'm just going to send to half the network.
Good.
But reciprocal with 4 seconds times 3 s. Right. This will be like 2 because 3 times 2 is 6. And 2 times 3 is 6, which gives us that. And 4 times 3 is 12. 7 times 2 is 14. 12. And we have to reduce that I'm having a hard time using this. I get it to 6 seconds.
6 over 7's right?
Oh, that's as long as it goes.
Yep.
So n equals 6 seconds.
And then we could have, if you look, we could have cross simplified before we even did anything because we have 4 and 2. So you could do like 1, 2. So that would give you the 6/7 right away. See that? Okay, good. Let's do 8.
Let's get rid of the 2. So minus 2 from the running.
Mm-hmm.
Multiply by this.
Good.
Put 9 over 1. So it's 3. So it's x 9 times. Hold on, it's 2 minutes.
Yes.
9 is divided by 1. 3 is 1. Oh, something like that.
Divide both of these by 3.
So I was going to get 1.
Okay, sure.
So they're both divisible by 3.
Mm-hmm.
3 divided by 3 is 1.
Mm-hmm.
And 9 divided by 3 is 3.
Mm-hmm. Simple as that.
And 3 times 5 is 15 over 1.
Mm-hmm.
So just 15. So that's equals 15.
Mm-hmm.
Awesome.
There you go. Okay. Try 10.
So K2 plus K4. In this case, K would have to be the same.
Mm-hmm. It's the same variable.
So I forget how to do these ones.
Okay. We were just doing the fraction work, so if we get common denominators, we'll be able to combine these two terms here.
Oh, okay. So times this by 2.
Mm-hmm.
First that means it would have to be 2K over 4.
Mm-hmm.
If you write it 2K over 4 plus K over 4 is equal to 9. So wouldn't that just be 3K if we combined it?
3K over 4.
3K over 4 is equal to 9. Oh, and now we can cross. Whoa, what did you call it? Oh, reciprocal.
Reciprocal. You can multiply by the reciprocal, yep.
Well, again, it would be 3 times 1 times 1 is 12. So 12 over 1K is equal to 12.
That's right.
It's starting to work faster in my head now.
That's good. It just, you know what it is? It just takes practice like anything else. Let's do 14.
14. Over. Do you move your paper? Just
Sure.
it's kind of black. Thank you. 2 over 3. Oh, sorry, 2 is 7 x. So times that by 2 times that 3. So here we get 4m over 6 plus 3m over 6 equals 7x. And those together we get 7m over 6 equal to 7x. Multiplied by the reciprocal.
Let me catch up here. Did you get a common denominator?
Yeah, 6.
6. So you multiply this is 4m
So
over 6.
I have 7 over 6.
Oh, good. You did.
7m over 6.
Good.
And then I just multiply by the reciprocal.
Good.
On both sides. That's the current state for that right now.
Good. Thank you.
So 6 over 7. Oh, 2 and 6. So divide this by 2, which gives 1, and divide 6 by 2, which gives us 3. What could I go lower than that? And divide it by 3, which gives us 2.
Let's see. Did you try to cross simplify here?
Yeah, I'm trying to cross simplify.
7s cancel.
Oh, that's easier. If I did do it the other way with the 2 and the 6,
Mhm.
I got the same answer.
Well, we want to simplify 6 over 2 as well.
Or we can also do that.
Yeah, you
It gives us 1/3.
can. 3, right? Divide this in the top and bottom by 2.
Okay, so you have to do it by 2.
Yep.
Which gives us 1/3. Or 3, 1.
3 over 1.
1, which is 1. So n is equal to
Check that.
3.
3. Yep.
Divided by 3.
And then so let's plug that back in and see if that's true.
Alright, so just to self-check.
Yep.
So 2, 3 over 3 plus 3 over 2 equals 7x. So 2 times 3 is 6 over 3 plus 3 over 2 equals that. We get the bottom denominator, which is still 6. Is that by 2? 12 over 6
Mm-hmm.
plus 9 over 6 equals 12 plus 9 is 21 over 6, and we will divide that by 3,
Mm-hmm.
which gives us 7x.
Good. So that's the
Oh,
same.
and we can even make it proper. It could be do 3 and 1/2.
Mm-hmm. And so we're checking it against the 7/2. So 7/2 is 3.5, or we had 7/2. So that means our solution that m equals 3 was correct.
Yes,
Okay with that?
exactly.
Okay, good. All right, that's a little bit of algebra. That's me.
Right.
See.
Word problems, I have difficulty with.
Yeah. Let's we'll get to that. I think it's a standard thing that most people have trouble with word problems. So we're like
I also have dyslexia. So
oh, is that right? Yeah, so it's hard to read.
yeah.
I don't really, you know what? Like, I don't get too caught up in word problems. I think we should do them, but I think like learning the math is the most important thing, and then extending it to word problems. So try something. This is algebra a little different.
All right.
Number 10.
10 or 13.
10.
So 2x minus 10 equals 6. Right. I'm going to get rid of the brackets, so I'm going to multiply the 2 by everything in the brackets.
Yeah, what you would call distribute.
Distribute, okay, I've always called it firework.
Oh, really?
I don't know
Interesting.
why. Well, just because you like draw.
Yeah, it's true. I never heard that before. So yeah, that might be like the proper term is distribute, and maybe the teachers like we'll call this fireworks kind of thing.
Okay. So which this gives us 2x, and then 2 times -10 is -20.
Uh huh.
So equal to 6. And then it's just what we were doing before.
Yep.
Which is plus 20 on both sides. So we get 26, 2x, 5 over 5, which is 13. So x equals 2.
Okay, good. Okay, you're clear on that. Where's my here? This is what I want to do.
The table.
Yeah.
So this is patterns.
It's like positive square root. What's
just positive and negative roots.
Yeah. I guess what we're talking about here is we're talking about perfect squares.
Oh, so the negative root would be negative 8.
Yes. So these are all perfect squares.
It'd go 8, 11, 7, 1, 9.
Mm-hmm. 169 is 13.
36 is 6. 100 is 10. 144 is 12.
Okay.
The perfect cubes is where I get mixed up.
Yeah. So let's do.
When you get up into the 7 and 8.
Yeah, and like let's see, what's the cube of
What? 1 is 1.
What's the cube of 2?
2 is 2 times 2 is 4. 4 times 2 is 8. 3 would be 27. 4 would be 100. No. Yeah, 100.
Mm-hmm.
So 4 times 4 is 16. 16 times 4 is 32. Oh, 64.
Good. That's right.
64. There we go. I used to have them all written down. 5 is 25.
I'm not even sure what 6 is, to be honest with you.
26 times 6 is 36. So 6 times. Oh, yeah, I can't do that in my head.
216. That's good. That's good enough.
Okay.
Okay, so let's look at square roots here. Number 9.
The square root of 225. Well, wouldn't it be 25?
Let's see. Yes, 25 times 25 is 225. Is that true?
I'm not sure.
Let's
I don't
try.
think so. I think that's too low.
Yeah, that's right. It is.
So it have to be less than. But it couldn't be 15. Is it 7?
Okay.
That's too low.
That's good. So let's talk
I don't know
about
how to do that.
let's talk about a method for figuring out these square roots using factor trees.
Oh, factors.
Yes. So factoring means what two numbers multiply to give you 225. So you can be like, oh, well, this is divisible by 5.
5 and what though?
Yeah, so like we would do, we didn't know we had to do this. See what I did there?
Yes. 45. And then 5 is as old as you know.
That's called, you would say that's prime. There's no factors of 5 except 5 in itself, so it's prime.
Isn't that 3, 5, 7, 11, 13, 15?
15 is not prime because 3 and 5.
Oh, 3 and 5.
Yeah. What's the next?
7.
17 is prime.
17, 19,
Uh-huh.
23.
23 is prime, I think, yeah.
And I don't know, that's the much I can remember.
Yeah. So those are a set of prime numbers that are good ones.
You probably won't have to go much higher for that.
No, you won't.
Since 23 is already pretty high.
Yeah, it's unlikely that you will. You're right.
Right, so 45, 5 times 50 would be 10 and 5, so it'd be 9 and 5. And then 9 is 3.
Mm-hmm. Okay, so you have the prime factors of 225, or 3 times 3
Say
times.
like 5 squared plus 3 squared.
Close, not plus though.
Oh, times.
Times.
5 squared times 3 squared gives us 225.
Mm-hmm.
That's just another way I can think of it.
Yeah, so you could rewrite this. You could write 225 like this,
Mm-hmm.
and this properties of radicals means you can rewrite that like this. I could split this.
I remember learning this.
Yeah. So this and 5 squared. That's just this, and this is just this. So it turns out the answer is that. That's one way to do it. So 15 times 15 is 225. It was 15. You had said that originally.
I think I didn't say that yet.
But this is a way to kind of like a lot of these you won't.
Make sure.
Yeah, and then if it's not a perfect square, you can simplify the radical. Like 75 is not a perfect square, but can be simplified. So this is like a method to deal with square roots, and it has to deal with factoring.
Right.
Okay.
All
So
right, can try one.
yeah, let's do a bunch of these,
Awesome.
and then we'll leave it for homework too. Number 18. Actually, you can call this homework too, because if you want, because I'm going to take a picture of it anyway.
All right, I'm gonna take a picture of it.
Yeah, and I'm putting it on canvas this time. I think I don't know what happened last time. Someone else has your assignment. I can tell you that.
Someone else has it. All right. Awesome. Which one did you say to do next?
8, 10. We'll just work it.
Read the square root of 18
Okay. So the square root means what two numbers multiply together that are the same equal 18. So it's possible that what's in here is not a perfect square. So this is a perfect square. This is 18 is not a perfect square. But we can simplify this and see if there's any perfect squares in 18.
I did 6 and 3.
Mm-hmm.
And then I did from 6 to 3.
Check that. 2 and 3.
Oh, 2 and 3, sorry.
And so the prime factors here are this.
Yes. Oh, okay, actually, no, that makes it easier.
Yeah.
Because the 3 3's were missing.
Okay.
So it would be, if I divided the square root of 3, 3 squared times the square root of 2.
You can. So I'll show you 2 ways to do this, but one way is to do this. So you can rewrite 18 as 3 squared times 2.
Just like that.
Yeah. Another way I teach this is, the way I do it in my head sometimes is, if you break 18 up, you get 2 times 3 times 3.
Yes.
When you're trying to simplify radicals, it's almost like you're playing a card game and you're looking for pairs. So if I have a pair here, 1 can come out. So the way to simplify this is to do that.
So if you have a pair, take 1 away and put it to the front.
That's right.
All right.
That's
take a picture of that.
yeah. This mechanism works pretty well. Instead of doing this, because then you might have all different kinds of pairs going on here: threes, twos, fives, and each one gets pulled out and you multiply them together in front.
75 wouldn't be another square. So can I try that?
Yeah, let's try that.
Class ends. So 75. I know 25 can go into 3 times. 3 is a prime number. 25 we can get 5 times 5. So 3, 5, and 5. So if we leave it with 3, we go 3 times 5 times 5. Even pairs. So constant 1 root front. So we have 5 and the square root of 3. Or 5 square roots of 3.
Or you'd say 5 times root 5 root 3. This would be the answer. This is a simplified form. So in your calculator, if you did like square root of 75, second square root of 75 is that number. And then if I also did 5 times the square root of 3, same number. So this is a simplified form because we pulled out the perfect squares. Okay?
All right, so for my homework.
Yeah, check Canvas. See if you can see it.
Okay, awesome.
I want to make sure we get that working. Oh, still confused.
Homework 1, radicals.
So you should be able to open that and see these. And so I would spend spend an hour if you can. If you can't get through them all, that's fine.
Okay.
And if some of them will have variables that you're confused about, just skip them and then just do the ones with real number with the numbers in it.
Real numbers?
Yeah. But if there's a y squared here, it just means this means y times y. So there's a pair of y's. So one y can come out. So the answer to 14 is 4y.
4y. Could it not be y4?
It could be. But usually it's written.
Interchangeable.
Yes. So you would like factor this.
Okay.
And you're like, ooh, I got a pair of y's. Or a pair of 4s, one comes out.
And the 4s, one comes out. And just because the 4 is there before it.
Usually you always write the constant before the variable when you write the.
Right.
So you could write like that, but usually it's always written like this.
Yeah, that makes sense.
Okay.
So the answer would just be 4y.
Yeah, and if those confuse you with the variables, just skip ahead and do the numbers. I'm more interested in like this thing where make a factor tree, find pairs.
I'll be sure to show my work as well.
Yeah, show your work and upload it, and I'll take a look at it. All right, very good, Jack. Thank you.
Thank you.
Talk to you soon.
See you Wednesday.
Yep, great. Bye. All right, that was Jack from Spain. He's a soccer player, and we are doing pre-calc. We're doing an algebra review for pre-calc. So we're just going through, at this point, real number operations, fractions, and we ended with radicals, factoring, and simplifying radicals. So you did a good job. Until next time, we'll see you soon.